15 again, doing Leetcode 75. This is leaf linear or leaf similar tree 872. It says consider all the leaf of a binary tree from left to right order. The values of those leaves form a leaf value sequence. So in the tree above, we have the leaf value sequence 6, 7, 4, 9, and 8. The two binary trees are considered leaf similar if their leaf value sequence is the same. If they return true if and only if the two given tree with nodes root 1 and root 2 are leaf similar. So this one is true because they are the leaves in this order. The sequence that they make is equal to each other, and these two are not equal to each other because they're not in the same sequential pattern. So the way that we can think about this is using when we all look at tree problems, we should look to try using depth first search. So essentially we try to look at through an entire branch, go back up. So like we go all the way to 3, 5, and 6, go from left to right. We go to 6, go back up, and then start going to the right or downward. So go to 5, back to 5, to 2, to 7, and go back up, go back to 4, and do the same thing on the right hand side of the tree. The way that we can approach this problem, we have two roots. We can create an array for both of those trees, and then we can check to see if all of the elements are equal to each other. And using Python, you can just simply check if using the equality operator to check if the arrays are equal in the same order. And then we have to create a recursive statement with depth first search. What we can do is we can check that we have two base cases. So the first one being that if it's not like a root or if it's not a tree or anything at all. So once we hit a null value, we just return out of the recursive function. And the second base case is that if there is no left or there is no right node to go to, that means that this is the leaf node. So we can add that into the arrays that we were talking about here. And afterwards, after running both of the functions, and also we have to iterate down to the left and the right side of the tree. And otherwise, at the end, we'll just return to see if the two arrays are equal to each other. So yeah, we can create two arrays to start off. Array 1 and array 2, which is just equal to two empty arrays. And we can create our first what we can do is we can say that we're going to create some depth first search function. We're going to use on root 1 and the array 1. We can run another depth first search on root 2 with array 2, and then we'll return to see if array 1 is equal to array 2. And what we would do here is we're going to define the depth first search function, which takes in a root, takes in an array, and then we'll check if the root is none. So if not root, or if the root is not a valid tree node, then we can just return if not root dot left and not root dot right. We can append this value to the array. So we just get the root value and append it. And then all we'll do otherwise is that we'll just, or in every case, what we'll do is we will run the depth first search on the left and the right. So we take in the array as well, and that should be the solution.